So this is our second part of the video wherein we'll be implementing the circuits which we have made in the note. So let's go to the, we are already into the simulation mode, and let's go to the clipper circuit. Now you can see here you have a simple shunt clipper over here. Let me zoom in this one and just check over here. Okay, so VOL probe 2, VOL probe 1, we can rename it, and we can rename it as V in, and we can rename VOL probe 2 as V out. So now in the output waveforms we'll have V in and we'll have V out. Okay, so this is a simple shunt clipper. Whether it's a positive or the negative clipper, we should be able to know it by now. So now let's look at the orientation of the diode. Since the N side is connected to the positive of the, since the N side is at the top and the P is the bottom, so that means during the positive half cycle, the diode will be reverse biased, and the circuit will be open, and at the output the positive waveform will appear, whereas at the negative, during the negative, diode will conduct, and the output waveform will be 0. So now let's just go to the file, let's save it, go to simulation and run the simulation and to check what waveforms we are getting. So okay, orange one is the input and the blue one is the output. So this is simply our negative shunt clipper. So the negative half is clipped off. Let's separate the two. In pin number 2, V out, yeah, apply, and you will see. So this is your V in, and here you get your V out. So simple. You can make a distinction of the two, your input and your output. So this is a simple negative clipper. So we'll save the waveform as existing project. It's the waveform. Project is the negative clipper, and let us save it. So okay, it says the waveform exists. Let us rename it. Save as existing project waveform underscore 1, project owner, okay, myself, and save. Now to the same circuit we will try to add a reference voltage. That is, we'll now add okay, it's a negative clipper, it's a negative shunt clipper. Now let us add a DC voltage to it. So we go to the EE library, we pick up the DC voltage source. Here we place it somewhere here because we have to connect it with the diode. We take the diode out, okay, or keep it like this. Let's just delete the connections first. Now we are going to bias it. So let us just keep diode like this. Let us keep the voltage waveform like this. We can change the orientation of the waveform, we can change the orientation of the battery, we can do anything. Okay, now so first we had a negative shunt clipper, and now we need to see whether the orientation is okay or not. So we can do it anyways. So let me connect it, like this. Okay, so it is connected, and let us connect this part also. Okay, so this is all connected now. Now V1 is 1 volts, and here input voltage we have, what do we have? It's 0, 10 and 50. So we have changed the attributes. The maximum amplitude is 10. So peak to peak will be 20. Now look at this V1. V1 is forward biasing this diode, whereas V2 is reverse biasing the diode. So we need to compare the magnitudes when so till the time when V2 is lesser than V1, that means up to a voltage of 1 volts, the diode will be forward biased and V out will be only equivalent to V1. But when your V2 becomes greater than V1, your diode becomes reverse biased during the positive half cycle and the diode will be open. And then your V out will follow V2. That means your V input. This one, your sinusoidal. So let's just save it and simulate it. Whereas the negative half cycle, during the negative half cycle, your diode will be forward biased because of the V2, that is V in, as well as V1. So in both the cases, it will appear. So here we can see it. Okay, so you can see it is simply V in is your orange and this one is your V out, that is blue one. So if we increase the magnitude simply like this, let us increase it to 3 volts. You will see there will be a change. So it is 3. So it's, let's go to save and run. Okay. So this is clipping below the reference voltage. Okay. And just separate the two. So you can see it. Okay, now we are increasing the value of the reference. We have increased it to 3 volts. So it is here. Okay. And okay, now it has gone to, from 1 it has gone to 3 like this. Here it was only 1. Now it has gone to 3. Okay, and let us change the orientation like this. And let's observe whether it will be clipping above or clipping below. You can see it. This is clipping below. So it's a biased negative clipper. So it is a biased negative clipper. Okay, now biased positive clipper is change the orientation of this and change the orientation of the diode. I'm making one circuit and from that obviously I am showing you here because though there's no need to draw the circuit again and again. So it's save. Let's go to simulation and run the simulation. It's a biased positive clipper. You can see the positive half has been clipped off. The visibility can be increased if we separate the V out and V in into the two separate subplots like this. You can see it like this. Okay, so up till 3 volts it's like this, and above the 3 volts everything has been clipped off. So if we change the value from 3 to, suppose we keep it as 2 only, you will see that after saving your project, after saving your schematic, when you run the simulation, the values will also be changed. You can observe the change in the values like this. So see, now with respect to the previous waveform, it has now reduced. Okay, so it's like that. So this is also a shunt clipper. Biased negative clipper, biased positive clipper, negative shunt clipper. Now let's go to the series part. Okay, I guess these waveforms will be quite easily available. I'll just need to save this waveform. I'll save only this one. Let me just close this. Don't save. Yeah. So let me save it as save to existing. This is waveform underscore 2. I'll write the name, and the project is mine, and let me save. So it has been saved successfully. Now make another circuit which we have already made. Okay. Now what we do is that we make another circuit. New schematic. Okay, so here is our new schematic, and in this schematic what we'll do is we will make a series clipper. Now biased series clipper. So what we do is we first pick up the DC source, we place the DC source over here, so it's done. We zoom it a bit and like this, and we change its orientation. So right, so I'm rotating it like this, and the value is this one. I have to pick up a diode as per the circuit diagram which I have made. So I'll pick up a diode and I will connect it like this one. Okay, so I'll connect it like this. Okay, I've connected it, and then what I'll do, I need to take a resistor. I'll take up a resistor. Okay, here I'll place it somewhere here. I'll then keep on rotating it. Select it and rotate it. Okay, so I've rotated it, and what all I need to do is I need to have another input source, that is the AC source sine. So this is the sine. Okay, so I'm picking up the sine. Okay, I'll change the attributes first. I'll do it as 0, 10 and 50, what we normally do. Okay, so it is like this. Now we need to connect it and add the probes. So first let's make the connections from here to here. So this connection is done. Then make the connection from here to here, and this connection is done. Let's make the connection from here to here. This connection is done. So take up the connection from here to here and then to this connection, and let's make the connection from here to okay, and take up the ground connection is at the bottom like this. Take up the voltage probes like this. So the voltage probes, it is this one is the V out, and another voltage probe, this one is the V in. So we will rename it as V out, and we will rename this as V in. Okay, so this is done. Now this is a series biased clipper. So the value of the reference voltage is only 1, or the DC voltage is only 1. So let's go to the save as, save to an existing project. Okay, project is this one. Let me go to save. So it says sheet 1 exists, so I have to save it as a new project. Save as a new project. Title will be the biased series clipper. Sorry. We'll go to save. Then go to simulation. So we can see it. This is simply a biased positive series clipper. Now what is the difference? That 1 volts from the top has been clipped off, or it has been subtracted from the output voltage waveform. So if you increase, because you whenever it is series, you have to apply the KVL there. If we increase the value of the voltage here, let me just change the value to 3 volts. You can see there will be much change. The change can be seen when we simulate it. So you can see that 3 volts has been subtracted from the output voltage waveform, and we can separate the two. Okay, so see, the peak voltage, which is the 10, has now been reduced by a factor of V1. So that means while applying the KVL and taking the sign conventions, the VR has been subtracted from the V in, and that has defined the peak of V out. And then let's make some changes. Okay, let me save it as file, save as existing waveform underscore 1. Okay, so let me save it. So I've saved it. Now again, for the series part, I'll do another thing, that is I'll take up this battery source from here and I will use the battery source here, that is with the resistor. I'll delete it. Okay, I'm rotating it now. So now it is done. I'll just take it here. Okay, and connect it. So this part is done. So now you have diode D1, you have a resistor, and you have V1. So this is again a series clipping, but with the voltage reference in shunt. So let's check the waveform. We'll go to file, we'll go to save again, and we'll go to simulation and run the simulation. Okay, you can see the output waveform looks like that only. So the portion of the waveform, input waveform, which is below V reference has been clipped off, and the input voltage above VR is in the output. Okay, so we'll name it as waveform 2 and let's save it. Okay, so in this manner we can have many different combinations. If we change the orientation of the battery, obviously the result would be simply the opposite. Let's try it. We can go to file, we can go to save and run. Okay, it has not made a difference. Yes, it's the same. Yeah, it's the same waveform, but there's a difference. Now it's just like the negative part of the battery. So the value of the battery is 3 volts, you can see, but it's minus 3. So here all the value of the waveform below minus 3 has been clipped off, whereas in the earlier it was plus 3. So plus 3, it was above the reference. Plus 3 ke niche jo bhi tha, that was clipped off. And now since we changed the terminals of the battery, now everything below minus 3 has been clipped off. Now if we want totally the reverse, we need to change the orientation of the diode. So then it will be like the reversal of the, yes. Okay. Okay, just go to, let us go here, this part. I guess the connections are not good. Uh, so here is our waveform. So that is all, the entire waveform above -3 has been clipped off by changing the orientation of the diode. So we can just separate the two by separating the panes, plot panes, by applying it like this, and then again. So we can see it. It's simply the input waveform is sinusoidal, whereas the output waveform, the upper portion is entirely clipped off. That means 0 to 10 does not exist. Whereas since the battery is -3, so -3 below the reference, it is there. So this is known as clipping above VR. So that is clipping above the V reference. Okay. And then what we can do is a combination clipper. Okay. So we'll have so now we'll have a combination clipper. Going to this, picking up the components and designing it in the same manner. So first you would need to have a resistor like this, zoom it, then we need two diodes, first diode, then second diode, like this, and we need two battery sources. First, this is a battery source, and then we need another battery source like this, but we need to rotate it like this. Okay, and now we need to join them. So let's join them. At the input, we need to have a sinusoidal voltage source, and which is here. Again, the connecting wires. Okay, changing its parameters. Simply 0, 10, and 50 hertz. Putting up a ground connection. Okay, and then putting up a load resistor. Okay, rotating it. Okay, using the connecting wires like this and like this. Putting up the probes. because now we know that the it is sinusoidal. So V1 we are keeping as 1, V2 we are keeping as 1. So only 1 and 1 will be subtracted from the peak, that is 10 and 10. So let's go to File, Save As, save to a new project. Title of the new project will be Combination Clipper. So save. So it has been saved, and I'm going to simulation and run. So it's only showing me VOL probe 1. It's not showing me probe 2. Let me check what is the problem. Oh yeah, probe 1. I'm using only. So it's better I use 2 probes. In order to understand it better, let us use 2 probes. So this is your V in and this is your V out. Okay. So let us see if we are able to observe it. What are we able to see? We are able to see that this orange is the output one. It has a magnitude of only +1 and -1. So go on. So this is clipping above reference, clipping below reference, occurring in the same circuit. So if we increase the magnitude of V1 up to, for example, 5 volts, and we increase the magnitude of V2 up to 5 volts, so what we'll see is that above 5 volts, both in the positive and the negative direction, will be clipped off. So this is go to save, simulation and run. So now we can see it. So see, so this is your blue is your input waveform and this one is your output waveform. Let me also take a screenshot. So this is a good graph. So we save it as existing project waveform underscore 1 wheel name, and it will be my project. And let me see. So these ways you can add up, you can, change the magnitude of the reference, and accordingly your output will be changed. So series, shunt, clipping above, clipping below, we've all done negative and positive. This is all done. So I hope you'll practice it also on your Easyeda platforms.